All right, lesson 1D. In this lesson, we're going to talk about some angle pairs, how angles work together. When we are working with geometry, we get lots of angles, and I know like we're building something like these roof trusses. Lots of angles going on, lots of geometry and measurement that needs to happen there. And these trusses come in all different types, depending on what type of house you want to build. And we got lots of different angles going on here in between all these, okay? And all these come in different angle pairs, all right? Angles that are next to each other and relate to each other. And let's see how we can work with those, all right? So we got some angle pairs. Hopefully you got your notes open. We're going to go through this together. And so let's see. First type of angle pair we have are adjacent angles. And let's draw some angle pairs together like these, okay? So we get a hang of it. So adjacent angles, they share a side, all right? And so here we have one angle. And now we're going to make it share a side. And we should say this, and it also shares a vertex. And a vertex. All right, so we're going to share a vertex here with an angle. So there's one angle, and another angle would be like this guy here. Okay, so let's call these maybe angle 1 and angle 2. Those are adjacent angles, all right? Next, we have a linear pair. So a linear pair are adjacent angles that are made by intersecting lines. That's kind of not the world's best definition, but it'll work for us. So if we have intersecting lines right here, okay, and we pick two of these that are adjacent, let's number them angles 1 and angle 2. These are a linear pair. Angles 1 and angle 2 are a linear pair. All right, they're adjacent, made by intersecting lines. Now, if we look at these opposite angles, these would be called vertical angles. All right, so let's draw some vertical angles. So whenever we get intersecting lines, something like this, here's one, and another line that intersects that, and we get vertical angles. These are opposite angles. Let's call this angle 1 and angle 2. Those are vertical angles, okay? They're opposite. We have another pair of opposite angles, vertical angles up top and down below, okay? So vertical angles, all right? Supplementary angles, these are angles that add up to 180, all right? So let's say we have an angle, something like this. So here we have an angle, maybe we'll call that angle 1. And let's say we bring in another angle like this guy that we're going to put next to it. Notice this angle, when we put it together, they make a linear pair. They make a straight line on the bottom. See that straight line going on right there? Right there, okay? They make a straight line, okay? But they don't necessarily have to be connected. So here's angle 2. These guys are supplementary. Supplementary add to 180, okay? Complementary angles are going to look something like this. Here we have our angle 1 again, but now these angles add to 90, all right? So I've got my angle 1 here, and now if I have this other angle here, all right, looks like these guys, if we were to put these together, these guys are going to make, oh, that angle's falling apart. These guys are going to make 90, okay? So if angles 1 and angle 2 here, these guys add to 90, then that would be complementary, okay? So complementary angles add to 90, and they like to complement each other. You can think of it that way. One angle says, hey, you're right. No, the other angle says, no, you're right. No, you're right. No, together we're right, because we both make 90. All right, not too funny. So let's cruise along. Next page. Actually, down at the bottom there for you, I think. So if we take a moment, let's see if we can name some adjacent angles on a linear pair and a complementary, all right? So just kind of get the idea what's going on here. Let's look at the first one and then maybe have you try to name some, okay? So if we name a pair of adjacent angles, okay, can you see two angles that are adjacent? There's lots of them, a whole bunch. We could pick lots. We could pick, how about this angle here? This is BPC. This guy right there. And what other angle is adjacent? What's connected to it? Well, maybe this guy right here. How about this one? DPC. That would work. That guy right there. Okay. That one's connected to it. So angle DPC. That works. That's an adjacent angle, all right? So try pausing it here and try finding a linear pair. Find two that are complementary, two that are supplementary, and two that are vertical angles. Did you find some? Well, let's check it out. Linear pair, they make a straight line. Well, let's see. How about these two right here? They make a straight line, EPA and APB, all right? So the EPA, what's that, the Environmental Protection Agency, something like that. We got the angle APB, that one's there. So those two make a nice straight line, all right? Complementary, add up to 90. Well, how about these two guys right here? We've got angle EPD and DPC. EPD and DPC, those guys make a nice 90-degree angle, all right? All right, what about supplementary? Remember what supplementary adds up to? They add up to 180, right? Well, look at these guys, 126 and 54. Did you find those? So they add up to 180. So there's our supplementary angles. That works good. Angle EPA and angle EPD. So that's these guys right there. Okay. You could also use the same ones we use for the linear pair, because a linear pair turns out they're going to be 180. Now a vertical angles, now these are a little tricky because there's a lot going on. We're looking for intersecting lines. There's two lines that intersect, and we want angles that are opposite. So how about this one and this one? Those are opposite of each other, all right? So let's try that. So we've got APB, and then we've got this one here that's opposite of it, made by opposite rays, angle EPD. All right, so those are vertical angles. Good, let's go ahead and see some more how we can work with these angles and their special relationships. So did you catch on to the fact there that a linear pair and the supplementary were the same? Actually, it's because if you're a linear pair, well, you've got to be supplementary. These two angles make a straight line, and we know that this straight line here, right there, that angle is 180 degrees, okay? So that kind of makes sense. This is something that we call a theorem. This is our first theorem, all right? A theorem is something that we can prove to be true. Linear pairs are supplementary. Okay. Do you remember what that word supplementary means? They add to 180, all right? So here we have two angles. They add to 180. So we want to find out what x is. So we want to find the measure of the angle, first of all. And so we're going to need x to do that. So since they add to 180, we've got these two angles, this guy and this guy, the two measures. And we know that one plus the other, since they're a linear pair, because they're connected, they add to 180. So we can make an equation out of that. 3x plus 2, whoops, and 2x plus 18. All right. Now we can put those together. We have 5x. Put the 2 and the 18, we get 20. All right. Then we're going to subtract 20. I get 160. All right. And divide by 5. And let's see, 10 goes into 160 16 times. So 5 is going to go into there 32 times, all right? 32 times. So 32 is what x is. The question we wanted to find is the measure of each angle. So we got to plug that thing in for x here. So we have 3 times 32 plus 2. That's going to be 96 plus 2, which is 98 degrees. All right, and then the other angle has to add to 180, so we can plug that in, and we get 2 times 32 plus 18. That's 64 plus 18. 64 plus 20 is 84. So 2 less than 84 is going to be 82, and that's what we kind of expect. All right, so that's how we can find an equation and find out what x is to get the measure of the original angles. What about those other angles that are formed by intersecting lines, those vertical angles? We are going to use vertical angles all the time, all right? So what do you think is true about these two angles over here? Do they add to 180? Do they add to 90? What's going on with these things? Well, if you guess that they add to, that they're the same actually, then you're right. They are congruent. They're exactly the same. So the word, remember, the word is congruent. Congruent means the same measure, all right? And we're going to prove that to ourselves real quickly because we can do this, all right? We can say, well, these two angles have to add to 180. And this is how we write that. Measure of angle 1 plus the measure of angle 2 add to 180. And then these two angles have to add to 180, right? Because they're a linear pair. So we'll write that out. Measure of angle 2 plus measure of angle 3 has to be 180. And since these both equal 180, all right, we're going to get a little tricky here. 1 plus 2 makes 180, and 2 plus 3 makes 180. So these two things right here, 1 plus 2 and 2 plus 3, these things have to equal each other. So we're going to put these together, all right? We're going to go measure of angle 1 plus the measure of angle 2. That's this first box up here. Measure of angle 2 plus the measure of angle 3. That's the second box here. We know that those are the same things, so they're equal to each other. All right, I don't know what the measures are, but I know those pairs are equal. And then last but not least, I can say, let's see. Let's go ahead and subtract whatever the measure of angle 2 is. I don't know what it is. Let's subtract that. And we get this. Those go away. And we're left with the measure of angle 1 equals the measure, these guys go away, angle 3. So 1 and 3 are the same. And that's kind of what we were hopefully expecting. So these vertical angles 1 and 3 have to be the same. So if this guy's 72, then its vertical angle over here has to be 72 also. So we can say the measure of angle 2 equals 72 degrees. Now remember, these guys are 1 and 72. These guys have to add to 180, right? So if we do 180 minus 72, we can see that measure of angle 1 is 108 degrees. All right, so let's show a little work. That would be a good thing, huh? So this is 180 minus 72, which equals 108 degrees. That's measure of angle 1. And if this guy's 108, then its vertical angle across has to be the same. Measure of angle 3 is also 108. All right, there's our angles. So vertical angles are congruent, linear pairs are supplementary. Which brings us to our last little example here. If we have two angles that form a linear pair, so now we just got some words here. I think we're going to want a drawing. We got two angles make a linear pair, and then we know that one measure is 4 times the other. We want to find the measure of each angle. All right, how can we do this? You might want to pause and think about it. Maybe try drawing a picture or think about what that picture would look like. We got a linear pair. Remember, a linear pair makes a straight line. Okay, so we got a straight line. When you put a linear pair together, we get a straight line. Two angles that make a straight line. All right, and we know one of them is 4 times the other. Well, I don't know how big the other is, but I know whatever this is, this guy has to be 4 times bigger, right? So if one is x, the other one's got to be 4 times x. Not too tough, huh? Hopefully. So these two guys, they make a linear pair, and we know that a linear pair adds to 180. So these guys are 5x equals 180. A little bit of algebra now. We're dividing by 5. Let's get rid of that 5. 180 divided by 10 is 18. And there's twice as many 5s as that, so there's 36. 180 divided by 5 is going to be 36 degrees. So there you have it. We found one angle is going to be 36. And then if we do 4 times x, or really 4 times 36, because we now know that x is 36. 4 times 30 is 120. 4 times 4 is 24. This is going to be 144 when we put those together. And there's our two angles. All right? So, pictures really important in something like this. All right. So, we got linear pairs, vertical angles, supplementary and complementary. And these pairs are really useful. So, look for them, use your algebra, and you'll do real well at this. All right? Good luck.